the data on it. The jerk is the third derivative, and we've already kind of talked about that. We're going to do the derivative of the cosine function and the derivative of the other trig functions. I'm going to assume you don't know what a cosecant is. You should know it, but I'm going to assume you don't. Okay, so we're going to use our graphing calculator, and we already know the answer here. We're going to look at the derivative of the sine function. In fact, before we do that, well, let's go ahead and do that. Because I want to go a little bit further into it than that. Oh, here it is. And what I did was change mine to simultaneous as well, which is kind of cool. Well, we can observe it and see. Now make sure, press mode, because some people didn't have the right things. You must be in radian mode. If you get a straight line, a horizontal line, pretty much looks like a horizontal line, then you're not in the right mode. Girls. I'll give you those. You can wait 20 minutes. Yeah, I'll give you quizzes back. I don't have it into the grade yet. It just have the scores there, the raw scores, but I'll tell you what the conversion is. Okay, I went to simultaneous because it's kind of cool to see the sine function and its derivative graphed at the same time. Okay. Yeah, it's n derived. Are you ready? So I'm going to put in sine of x. And then I always zoom trig. I mean, it's always going to work. I've never seen it not work on the AP exam. Sine is right here. Okay, and then how do I get the derivative? Do you remember?
N derived on that.
Math. Okay, Riley, do you remember? 8. And then I want to get y1 in there. Since most of us have the old calculators, we'll do vars. It's a y variable. And function, y1. And then I want to find the derivative with respect to x. I want to see if I change x, how does y change? So you have to tell it x, because when you get into upper level math, you could have a function in 2 variables. And then you go, I want to do it for every value x, not just for 1 or 2. So I'm going to do x. Now when I graph this, it's going to graph it simultaneously. Now, pardon? Y1 comma x comma x. Because the first derivative is with respect to x. I want to see how y changes if I change x. And the last one is, well, where do I want to look at my derivative? I want to look at it everywhere. 7. Pardon? Okay, zoom, and I'm going to go 7. Okay, the thick one is the derivative. And I can try and do this, but I didn't get it. It doesn't pause for me. It does on an 83, I guess. And notice that what's my slope right there? It's negative, isn't it? Do you recognize that graph? It's the cosine. On the older ones, yes, not on the new ones. I wonder if on would work. Let me try it. I did. It doesn't work for me. So y equals, now I have to rekey this or I won't do it again. Now I'm going to graph. I'm going to press on. I know on will stop it, but will it continue it? You press enter, but that only works on the, oh, there it goes. Now I press on. Oh, look, I got a good spot here, because look at what's true about the slope of the tangent line right up here. I press on an 84.
It's enter.
But I'm afraid if I press on again, it's just going to go away. But well, let me try printing enter and see if that will do it. But you see what's happening here? Right up here from this maximum, the slopes are negative. What's true about the cosine curve? It's negative. Try this. Usually it stops it. Yeah, it stopped it. So I have to press graph again. You know what? I'm gonna try this. On. Little delay. I'm gonna press graph again and see if it'll continue. Nope. So there's an advantage to an 83. You can pause it. I did. Really? Okay, then that's the problem with mine. So if you press enter, you get the pause. Oh, there's pause there now. Maybe it's just a little slow. And I press enter again. There it goes. Mine just might be a little slow. Okay. Let me draw this picture down here. I think it got confusing in the last class. Here's the sine function. Okay. Now, let's just look at the slope of the tangent line. I like to find the zeros first. Well, that's a 0, and that's a 0. Well, what we're going to be doing in Chapter 4 especially is finding out what the derivative tells us. That means you have a plot on. Go over and turn the stat plots off. Now, what's true about the slopes here? Okay, guys? They're what? Positive or negative? They're positive. In fact, this is pretty steep. I'd say it's probably about 1. So these values must be positive. What about the slopes over here? They are negative, which looks like it's pretty fast right here. That's negative. I'm pretty steep, but then it gets less steep, goes back to 0. So it's going to come down here like this, and it's going to come back to 0. And now these slopes are positive. And that we can recognize this curve, I hope. Looks like the cosine curve. The derivative, now, what's this x? That x, this is an operator. No, we're going to prove it once and that's it. Now, this is an operator. Like you say 2 plus 3, we all know that means add those, right? Not a problem. This means find the derivative. It means find how y changes if you change x. We could be changing time. We could be changing an angle. We could be changing a lot of different things. That just tells you what that letter is. We will be going over that and over that and over that. So if you don't get it now, don't worry. It will happen. It's not dy dx. It's just d dx. That's like a plus sign. And it's this derivative of the sine function is the cosine function. Well, what do you think the derivative of the cosine function is? Well, should we find out? Now, I don't want to see, maybe I do. I don't think I want to see the sine graph, because we know what it looks like. So what I'm going to do is turn it off. So I go over here. Keep going. Oh, no, I don't want to turn it off there. I want to turn it off here. Press enter. And now I want the derivative of the derivative. Oh, that'll be slow. Should we just put in cosine here instead? Clear. Let's put cosine in here. Okay, here comes the cosine curve, and its derivative is the heavy one. Is it sine? It's negative sine. If you don't believe me, let's try this. Let's go down here, and let's make this that little circle trace. Remember where that is? I like those. And then we'll do negative sine of x minus sine of x. Now, should we turn the cosine off so we don't have to see it? Because there could be a lot going on. They're the same. Because remember, I have it all doing it simultaneously. Could have left the cosine curve there. The derivative of all the cofunctions will always be negative. Yeah, can you see the negative sign there? Okay. So, the derivative with respect to x of the cosine curve is negative sine of x. Now let's just do it once. Let's prove the derivative of the sine function. I might not have a lot of space here, but I'll try. We will use the definition of a derivative. Maybe this will work better if I do this. Let's do h minus rather than c. But it doesn't really matter. Okay, we all see the derivative there? What's going to happen is you're going to see a limit like that on the exam, and you're going to say, oh, I just want the derivative of the sine function. You're not going to want to do this, because this is hard. Okay, so it's the limit as h goes to 0. Now, in place of x and the sine of x, you'll put in x plus h. So that's the sine of x plus h. If you're still having problems with function notation, please come in and see me. We'll work on that. Minus the sine of x all over h. And then we get stuck. Because you're on the exam, you don't remember the identity for that. And did you ever do this identity in pre-calc? I don't know. You might have, you might not have. Okay, well, that causes a problem. Now, you don't have to know it for the exam. You used to have to, but not anymore. But I'm just going to expand sine of x plus h. Here's the a, here's the b, using this little formula. So it's the sine of x cosine of h plus cosine of x sine of h, right, minus the sine of x all over h. And you say, that doesn't help me at all. I had to use this identity right here. Yeah. And we don't require you know that. I'm going to regroup this. I want to put these terms together, and I want to change it to an adding problem. So it might bother you. So I have the limit as h goes to 0. It's the sine of x cosine of h minus sine of x. Then I have plus cosine of x times the sine of h. And this is what might bother you. I'm going to make that over h and that over h. This is not multiplying. This is adding. If you have common denominators, what do you do with the numerator? You add them, right? But you see that these are the same. Would you think to do this? Probably not. But you see that these are the same things. If the denominators are the same, then I would just add the numerators, and I get this line right here. Okay, I am now going to factor out the sine of x here. You're not ever going to be asked to do this, but you should want to see once in a while why something is what it is. And this is the cosine of h minus 1 all over h. And you know what? I can distribute that limit plus the limit as h goes to 0 of cosine of x times the sine of h over h. Pardon? I factored out the sine of x right here. I undistributed. So if you distribute this back, we get that. And then do you remember this limit as h goes to 0? Do you guys remember that one? It's 0. Now, does the limit as h go to 0 affect the sine of x? No, it's x, not h. Nope, it's the sine of x times cosine of h. So I could write it this way. Sine of x, the limit of that one times the limit, because limits distribute, which is kind of cool. We think everything does, but no, everything doesn't. This is 0, and that's just the sine of x. So the same thing here. H doesn't affect that. But what is this then? It's the cosine of x times the limit as h goes to 0 of the sine of h over h. What is that? That's 1. Sine of h over h as h goes to 0. If this had been an x, it wouldn't apply. They have to all match. So there it is. There's the cosine. Now, I don't expect you to repeat this. It's not a big deal, but at least you can see that it really is the cosine. This is 0. We looked at it graphically. I could prove it to you, though, if you'd like. I can do it algebraically. Well, it doesn't really matter what this is. That's 0. Okay, Jack? Pardon? Two terms, really. Another way to look at it is if you let h go to 0, what's the cosine of h? It's cosine of 0. 1. What's sine of x minus sine of x? 0. And then I put it all over h. And then I would just be left with this little piece. And that's what I did in the other class. Well, it's not really wrong, but this is better. Yes, it is. Okay. So let's fill this in. What's the derivative of the sine? The cosine of x. The derivative of the cofunctions are negative. Because you have to memorize these. And I have some signs that we can put up there, and I leave them up there all year until the AP exam happens. Then they have to come down. That's why they're down. Well, our next goal is we want the derivative of tangent, we want the derivative of cosecant. Well, now this is where I said I assume nothing. If you have the sine of x, then what's 1 over the sine of x? That's the cosecant. If you have the cosine of x, what's 1 over the cosine? Do you remember? That's the secant of x. There's only 6. It's either a over b or b over a. It's just the reciprocal, that's all it is. And the tangent of x is equal to, I'm not equal to. And I have 1 over the tangent of x is what? Cotangent. And that's it. That's all there is. So if I want to find the derivative of the cosecant, you're going to want to memorize it. But in the meantime, since we don't know what it is, we better figure it out. I want the derivative with respect to x of the cosecant. Well, that's 1 over the sine of x. And then, if you didn't do the homework, you probably don't remember the quotient rule. Remember that one? Derivative with respect to x, I just want you to get used to writing this correctly. F over g is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. I wish we could just take the derivative of each one and divide them, but it's not right. Yes. That's the low d high thing. Okay? So it's low d high minus high d low over the square of low we go. Whatever works. Well, so now in a video. Okay, so what is the derivative of this? It's equal to the denominator times the derivative of the numerator. What's the slope of y equals 1? It's the slope of this line. 0. It's 0. Minus the numerator times the derivative of the denominator. We just did it. It's right down here. Cosine. All over the denominator squared. And that's a fine answer, by the way. Some of you simplified incorrectly, unfortunately, which is not a good thing to do. But it's negative cosine of x. Now I'm going to rewrite this a little differently so we can have a little more compact. What's this? Cosine over sine. Cotangent. Sorry, I don't have any room there. So it's minus cotangent of x. And I have 1 over the sine of x, which is cosecant of x. But it doesn't matter. You can remember it this other way if you want. It makes no difference. Cosine over sine is cotangent. 1 over sine is cosecant. You could have had it called, they could have chosen to do cosecant, cosine of x times cosecant squared of x. They could have done that way. because of this subtraction right here. And remember, the derivative of all the cofunctions is negative. Okay, here's what I do. I memorize a couple of them, and then I work the rest out. What about the derivative of the tangent function? Now, what is tangent of x? I have to use some trig. What's the derivative of the tangent? What's tangent? Sine of x over cosine of x. Good. Okay. So you should be doing it with me. So remember how to do the quotient rule? It's the denominator times the derivative of the numerator. What's the derivative of sine? Cosine. Then it's minus the numerator times the derivative of the denominator. Negative sine of x. All over the denominator squared. I prefer to write it that way. It's the only way you can put it on your calculator, by the way. Can't do cosine squared of x on your calculator. And then we simplify that. Because what does the numerator give me? Whoopsie. This gives me cosine squared of x. Two negatives make a positive. And hopefully you recognize that identity in the numerator. That's 1. Do you remember that from last year? Cosine squared plus sine squared is 1. So it's 1 over cosine squared. Yes. How can I write it without a fraction? What's the reciprocal of 1 over cosine? Secant. Secant squared of x. Well, not that bad. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. No, these are the derivatives. This is secant squared. We're going to get them all. Okay, ready? I think I'm on another slide. Okay, the derivative of cosecant, didn't we just do it? You may. It's just generally accepted that we change it to secant squared. Because you're going to see some of that. No? Can you see okay? There, is that better? Now, we did cosecant, so let's go ahead and fill that in. Actually, I know the secant. Cosecant was up here someplace. Where was cosecant? Oh. Was it on the other slide? Right here. Okay, so it's negative cotangent. So I'd like to write it this way. It's negative cosecant of x, cotangent of x. Remember, all the cofunctions are going to be negative. Well, let's look at a pattern here. If this is cosecant and that's cosecant, secant, what do you think this is going to be? It's not negative because it's not a cofunction. Secant of x. If this is cotangent of x, tangent. Now, I learned this one, and then I figure out cosecant. It doesn't matter. There's some you have to do, and then I just look for patterns. I already know the derivative of tangent is secant squared. So what do you think the derivative of cotangent is? Negative, not secant, but cosecant. Pardon? Only the cofunctions. So cosecant, cotangent, cosine are negative. When we reverse it, of course, it's going to get complicated. Now, you guys, the derivative of cosecant is, whoops, I hit the wrong thing. There we go. Let's find the second derivative, and we'll do this one. We don't quite finish it, but we'll do it. Now remember, if y is equal to the cosecant of x, The first derivative, remember, we go back up to our chart. Derivative of cosecant is negative cosecant of x times cotangent of x. Let's find the second derivative, because this should be what the homework is like. That's the first derivative. The third derivative is the jerk. So whatever we don't get done today, we'll get done tomorrow. Okay. What rule is this? There's a big time sign there. Product. Okay. So it's the derivative, do you remember that one? Of f times g. So it's f times g prime plus g times f prime. Okay, so y double prime is going to be negative cosecant of x times the derivative of cotangent. Well, guess what? I've got that written up there for me. What is it? What's the derivative of cotangent? Negative cosecant squared. And you can spend a lot of time, unfortunately, playing around with the trig and using identities to change how it looks. We're not going to do that. You just take the derivative, be done. Okay, then it's plus, and then it's cotangent of x times the derivative of negative cosecant. Well, it's negative because of the negative there. What's the derivative of cosecant? Still up here. Another negative cosecant cotangent. It will be positive. We had some issues in last class, so I wanted to write it out. It was my fault. The derivative of cosecant is a negative. So it's going to become what? Positive. Now, do I care if you simplify that? Not really. But we can. There's not much you can do. You can multiply that out. Y double prime, what happens to the two negatives? Become positive. It's cosecant what? Cubed of x. And if I multiply this out, it's plus the cosecant of x times cotangent squared of x. So if you check in the back of the book, they might do some trig identities to get a different answer. Who cares? That's why you go to the solutions and you just check. I'm fine with this line, to tell you the truth. Some of you simplified on your quiz, which wasn't a smart thing to do. Because what's cotangent times cotangent? This is not distributive. This is just associative. I multiply those together. You ask me a question. Yeah, we're going to do one more. Yep. Then we're going to get them back. Question? For what? Oh, I've got them. But you can put them up. Now, math team meets after school tonight. Everybody's invited to math team. First meet, it's on day off, your day off. You could letter in math team. Yeah. You get 20 points within the 5 meets, but you got to go to all 5. Unless you have a reason not to go. Okay. But I want you to realize that you guys are all invited. Even though I don't invite you personally, sometimes I do, but you're all invited. You're all capable, and you're going to find it hard in math, by the way. Some of it you haven't had. That's the reason why it's hard. Oh, okay, number 2, find the equations of the tangent line. Do you guys know what normal line is? Perpendicular. Normal means perpendicular. Put that in your notes. They might ask for a normal line on the exam. Remember how to find the perpendicular slope? Opposite reciprocal. Right. Now, I think some of the problems some of you guys are having with the homework is I go over, okay, this is what the derivatives are, and then you get to the homework and it looks like this question, find the equation of the tangent line. It requires you to do more. Last year you had worksheets and it was just find the derivative type thing. They're going to put more things together. So we are going to write the equation of a tangent line first. Because if I don't know what to do, I don't even know where to start. It says find the equation of the tangent line. Stop right there. It's y minus y1 equals mx minus x1. Can we all do that? Okay, it should be always, because you are going to have to do this more than one time on the exam. Could be even 4 or 5 times on the exam. Okay? That's the equation of a line. That's in point slope form. And then you look here and say, okay, I'd like the equation of the line. I need to know the x-coordinate, the slope, and the y-coordinate. You know the x-coordinate. X is -3. How am I going to find the y-coordinate? Well, I'm going to find f of -3. Now, this is going to be a calculator problem, but I'm still not going to use my calculator. If I do, I round to 3 decimal places. You're better off leaving it exact. So it's the cotangent of x, which is -3, over -3 squared. Anytime you substitute, you must use parentheses. I wanted to say you can leave it like that if you do the parentheses. It's correct. If you don't have the parentheses, it is not correct, and you will lose the point. It's the cotangent of -3 over 9. So if you just went right to this line without that middle section, you still would be fine. Okay, so it's y minus that ugly-looking number, whatever it is, equals my slope, and then it's x minus a -3. We're making progress. Steve, I don't care if I make the double negatives a positive. I don't care. The only time I care is multiple choice. Somebody in the back. Okay. Okay. Let's do the derivative on our calculator. Do you remember how to do that? Oh, I could be wrong, yeah. Sorry. Habit. Not a good one. Okay, so let's use our graphing calculator. We'll just do it on here. Well, you know, this isn't as easy as I think it's going to be. How do you put in cotangent? 1 over tangent. So I'm going to put in y1, or I'm going to get all messed up with my parentheses. So I need parentheses for the numerator and parentheses for 1 divided by tangent. Where's tangent? Of x. Then I got to close that parentheses. Close this parentheses. Actually, I think I might have too many parentheses there. That's okay. I'm going to match them up. I have an extra one, but that's okay. Divided by what? X squared. It'll tell me if I did it wrong. Okay, quit. And now we're going to do math. I'm going to go to 8. You see why I want to do that, not put all my parentheses in here? I already had enough trouble with my parentheses. And it's a y variable. Try not to go too fast. It's a function, y1, comma. My variable is x, which is always going to be x, and it's going to be at -3 until next year, in which case then it's going to be t's and stuff. It's at -3, right? And press enter, and there it is. If it's a calculator problem, don't forget to use your calculator. Okay, are you in radian mode? You got to be in radian mode. Oh, yeah, but you're doing it on the graph. You don't want to do it in the graph. You want to do it in the main window.
To the end drive.
Yeah. Yes, you might have messed up parentheses. I have too many, but that's okay. Better to have too many than too few. It's parentheses 1 divided by the tangent of x. Close those parentheses. Now close the first parentheses divided by x squared. That's cotangent. And that's not the derivative, that's cotangent. Now, you could do this by hand. I'd have to use a quotient rule, but I'm given a calculator, so why not? You did well. You did well. Okay, what will be true about the normal lines? I forgot to the other class. So it's y minus this thing. And then it's the reciprocal, so it's -1 over, oops, opposite reciprocal. It's 1 over 5.6 0.059. You may truncate. When in doubt, put all your decimals down because we don't look at these at all. You could write down junk and we don't even look at them. We only look at the first three. And then it's x plus 3. That's the normal. And then you could graph it if you want. No, you can round. But then if you round incorrectly, then you're wrong. It's the reciprocal of this. So I just flipped it. I wonder whose that is. Okay. That's it. Oh, yeah. See, that's what I think the problem is. You're used to just a straightforward, do this calculation, do this solve, and you're not going to see that this year. You're going to see all R3s and R4s. Can I teach every single problem? Absolutely not. I have to teach the concept. You have to apply it. That's what makes this harder. But you can do it. I promise you can all do it. Yeah, no, it's positive because it's negative of this, so it makes it positive. Okay? All of you can get 5s in here. But you have to do the work. It's not going to just happen without the work.